Hello and welcome to another episode of SIP Zoyus, your semi-daily dose of math curriculum. Our topic for today is going to be solving cubic and cube root functions. So the main thing that we want to note is that the cube root and the cube are inverse operations. They undo each other. And so when we look at this statement and saying that when we cube a cube root, that's just going to equal a, or give us what's underneath here. And when we take the cube root of a cubed, or something cubed, that's going to get rid of our cube and also give us a. Realize these both equal the same thing, and it doesn't matter in which order we apply them. We can have the cube root applied to the cube, and that is the same as a cube applied to a cube root. Right? Notice they can be on either side of each other. Okay, so our steps for going about this, it's going to depend a lot on our previous math knowledge. Mainly solving equations, we want to use reverse PEMDAS. So we want to just go backwards in PEMDAS and to figure out how to undo these equations and how to solve for our missing variable. And then the new skill that we're going to be adding on to this is we're going to use our cube to undo our cube root, and we're going to use our cube root to undo our cube. Because remember, these two are just undoing each other, and we're just going to weave this into PEMDAS, and this is how we'll solve equations. So let's go ahead and start this off. So we're looking to solve this equation. We see there's a cube operation in it, but we don't want to go straight for that because remember we're doing reverse PEMDAS, so we want to take care of the subtraction and addition first. So we want to get rid of 10. So we're going to add 10 to both sides. Okay. On the left, that's going to give us 2x times quantity x plus 3 cubed, which will equal 250. Alright? Again, we don't want to go straight for our exponent just yet, because we want to get rid of this 2, and even when we follow reverse PEMDAS, we see multiplication is what we want to take care of next. So, to take care of the multiplication, we're going to divide by 2 on both sides. These 2's are going to cancel, and we will have x plus 3 cubed, which equals 125. Alright? Now, we have our cube, right? We have gone to our exponents in reverse PEMDAS, and so we can now take care of our cube by taking the cube root of both sides. Remember, you want to take the cube root of everything on both sides when doing this. Alright, so in case you didn't know, 125 is equal to 5 times 5 times 5, or 5 cubed. So the cube root of 125 is just going to be 5. And the cube root of x plus 3 cubed, well, these will just cancel and give us x plus 3. Okay. Now we took the cube root, and some people might be thinking, do we have to write plus or minus outside of here? Normally we write a plus or minus when we're using square roots. Do we have to do this with cube roots? And the answer is no, you don't do this. And the reason why is because cube roots don't make everything positive. Cubes don't make everything positive. The cube of -1 is going to be -1, and the cube of -2 is going to be -8. We don't have a case like with our square function or our parabola where it's taking any number, positive or negative, and making it positive. Since we don't have those cases, we don't have to account for it by writing the plus or minus outside of our cube root. Okay? There's only one solution that's going to come from our cube root because we don't have that even multiplication to produce only positive numbers. So that takes us to here, and now last, we're just going to subtract 3 from both sides, and that's going to bring us to x equals 2. Just like that, that's what x is equal to. Okay, we solve that one. Let's go ahead and do another one. So this time we see a cube root in here, so we want to go ahead and get rid of our cube root, but in order, of course, we want to do reverse PEMDAS. So let's go ahead and get rid of our -2 by adding that to both sides. So we have 2 times the cube root of 5x plus 1 which is equal to 12. And then we're going to divide by 2. Sorry, hold on 1 second. Okay, sorry. I thought I saw an error in the problem, but there wasn't an error. So 10 plus 2 is going to be 12, and we want to go ahead and take care of the 2 that's multiplying our cube root, and we're going to take care of that by dividing by 2 on both sides. So that's going to give us the cube root of 5x plus 1, which equals 6. Okay? Now up next we have our cube root that we want to get rid of. And how we get rid of our cube root is with our cube. So we want to cube or raise both sides to the power of 3. Okay? So raise both sides to the power of 3. And that's going to give us 5x plus 1, which equals 6 to the power of 3. And 6 to the power of 3, I'm not exactly sure what that would be. I have to take out my calculator to figure out what that would be. And going to my calculator, we're going to have 6 to the power of 3, which is going to be 216. So that's equal to 216. And now we want to go ahead and continue to solve this. So now we want to get rid of the addition. So we're going to subtract 1 from both sides. And realize we're now back to getting rid of the addition first, because we have now gone all the way through our reverse PEMDAS, and we have come back to taking care of what's inside of our parentheses, or what's inside of our root. So we're going to subtract 1 from both sides, and that's going to give us 5x equals 215. And then 215 divided by 5, I believe that'll be like 75. 215, using my calculator again, divided by 5. Oh, no, that's equal to 43. So x is equal to 43. Okay? Alright. So, very last question. Now, this one is, there's a little bit of a curveball in it. It's a little more tricky, but you want to just take this one step at a time, and step by step. So, we do see that this is 24 equals n, 3 times n to the power of 3 over 2. And what you want to do is you want to take care of this exponent's fraction one piece at a time. So there's 2 ways you can think of it. I'll go ahead and do it the way with a rational exponent first. What we'll first do is we want to first isolate this. So we're going to divide both sides by 3. So we divide both sides by 3, and that's going to give us 8 is equal to n to the power of 3 over 2. Okay? Now, if we want, we could write this as 8 equals n to the power of 3 over 2. Oh, God dang it, what am I doing? We could write this as the square root of n to the power of 3. Okay? So we could think of it like this, and if we did this, we would then see a square root that we want to get rid of. And so what we would do is we would square both sides of our equation. And we would have 64 equals n to the power of 3, because our square would cancel with our square root. And then we could just take the cube root of this to get rid of our cube on our n. And the cube root of 64 is going to be, if I'm not mistaken, I believe it's 4. 4 cubed, yes. So the cube root of 64 is going to be 4, is equal to n. Alright, so that's one way to do this, and sorry, I lied a little bit. That's not the way with the rational exponent. This is turning it into a radical form, right? Radical is that kind of shape right there, and then solving by taking care of it part by part like that. Now, if you want, you could go about it like this with exponents and using a bit of fractional math. So what I mean by that is we could cleverly square both sides. And why would we do that? Why would we square both sides? Well, the reason we want to square both sides is because over here that'll equal 64, but that's not why we want to do that. This 2 will then multiply to this exponent. Raising something with an exponent to an exponent will then multiply this exponent into it. So we'll have n to the power of 3 divided by 2 times 2. And then in this fraction, 2 divided by 2, what's going to happen to that? Well, those will cancel out. And this is why I say cleverly, because squaring both sides will get rid of this fraction of 2. And notice how it has the same effect over here on the right-hand side. It's very similar and it parallels it. Okay, and from here, now we just want to get rid of our cube by taking the cube root of both sides, and that's going to give us 4 is equal to n. Just like that. Okay? And for anyone who may be curious, now you may shut the video off at this point if you like to, but if you are curious to see what if we maybe took a different route, or what if maybe we got rid of our numerator first, stay tuned for that. We're going to be talking about that right now. So for some of you curious people out there, you may be thinking, well, what if instead of squaring both sides, what if I took the power of 1/3 of both sides, or took the cube root of both sides? And let's go ahead and see what that would look like. So we could raise both sides to the power of 1/3. And again, the reason why we would do this is because this 1/3 fraction would multiply with our 3/2 fraction. And then these 3's could cancel out. So on the left side we would have 8 to the power of 1/3, or the cube root of 8, which is just going to be 2. And over here we're going to have an exponent. Gosh, how did this thing turn into a m? We have a 3/2 times 1/3, where these 3's will cancel and leave us with n to the 1/2. And then how we get rid of our 1/2, the same way we did before. Now we just want to square both sides, because if we square both sides, that'll multiply this exponent by 2. And then when these numbers multiply, right, 1/2 and 2, they'll cancel, go into 1, and 2 squared is going to be 4, leaving us with just n. And as we can see, n is still equal to 4 even when we do it this other way, so this means that method is good as well.